It's great to have you all on this evening session where we are here to discuss AI ML in cybersecurity. And to present and discuss this topic, today we have our very own ISC Squared Colombo chapter member and Chief Technology Officer, Just-in-Time Group, Niranjan Disanayak. He's a CISSP, SSC, CSSP. I'm also proud to say that he has various other qualifications as well, right? He's very experienced, very knowledgeable. He's been involved actively with the chapter in promoting the profession and also helping others pursue a career in cybersecurity. So without further ado, I invite Niranjan to start the presentation. And if you have any questions, please post them in the chat and we will take it up after Niranjan completes the presentation. And after he completes the presentation, we will also open the floor for a discussion. So those of you who don't want to type in a question, you can just unmute, open your cameras and ask the questions directly from Niranjan. And together we will try and answer every single question which is raised during this time. Niranjan, over to you.
Thank you very much, Sujit, for the nice introduction. So let me share the screen. Here, are you all able to see the screen now?
Yes, Niranjan.
Okay,
it's
cool.
Awesome. We are able to see it.
Okay, so actually, Sujit gave an introduction about me. So currently, I work as the CTO of Just-in-Time Technologies, and before that, I was working for Trend Micro, which is a principal company which develops cybersecurity and information security solutions. I was there for 5 years, and before that, I worked for Enable Private Limited, and I was there for almost 6 years as well. So basically, maybe I have met some of you, but maybe I am yet to meet some of you. But it's anyways nice meeting you on this platform where we can each collaboratively learn about various hot topics in the industry. And today also maybe I'll be able to learn new things from you. So it's a two-way thing always. So after this session, we'll have a discussion and we'll try to learn from each other. So just to give you a very brief overview about what to expect in the session. So first we'll try to see why machine learning and AI is needed in the cybersecurity field. And also, I mean, we all know why that is needed, but we'll just to get an introduction, we'll try to identify that. And we'll try to focus on the main categories of machine learning. So there are a few categories that we need to focus on when it comes to information and cybersecurity, because not all categories are applied in this domain. And then we'll go through few use cases that we see in our day-to-day lives in products and solutions and different technologies in the cybersecurity field. And also you will see that there are two modes of execution in machine learning as well. So we'll try to identify that as well. And also I'll walk you through some very famous products and how they have implemented machine learning in their product stack. So that will give you an understanding of how different vendors adapt these machine learning technologies to come up with different solutions. Then, as everything, machine learning also has limitations and inherent attacks. So we'll try to identify the limitations of machine learning models, maybe some of the famous attacks and how to defend against those attacks as well. So this will be a very high-level discussion on the subject because it's a very broad scope. So some of you might be very versatile in machine learning technologies, but some of you may be just starting on machine learning. And as information security professionals, we don't need to go into the depth of the implementation level or developing level of machine learning. We just need to understand how a solution or a product works using these technologies, so we can properly adapt them into our environment. So that's the main expectation, to give you some kind of breadth into this domain, so you can explore on yourselves and learn more, and ask questions from the vendors, and choose the right solution for your environment. Okay. So when it comes to machine learning and AI in cybersecurity field, so it's always better to think from a information security analyst perspective, because they face challenges every day when it comes to day-to-day operations and administration, configuration, and all. So it's always better to think from their shoes, because it will make your life easier, and it will make you understand why machine learning and AI is needed. So if we take detection, so now we know that there are a lot of products in our environment, right? Endpoint security, email security, network security, maybe DLP, privileged access management, SIM solutions, web proxies, ATP solutions. So there are so many solutions in our network security architecture in a layered manner. So we call it defense in depth as well. So all these solutions will be developing different alerts, or maybe logs, right? And for them to do that, they need to analyze packets, they need to analyze traffic, they need to go through a lot of bits like ones and zeros, right? So doing that is not easy, and to do it in a very efficient and effective manner, there should be sophisticated mechanisms, right? That's the first thing. So machine learning is needed to detect in a better way. So if you take a simple ransomware, it's very easy to identify simple ransomware using a signature. But when it comes to advanced ransomware, when it comes to different variants of a ransomware, it's not easy to do that using a signature. For that purpose, you need different machine learning technologies. Then correlation. So you might have heard about SIM solutions. Now we have SOAR solutions, and again we have XDR solutions as well. XDR means extended cross-layer detection and response. And to do that in a better way, you need to apply sophisticated algorithms on a data lake, which is created by collecting logs from so many siloed products. Okay, if your network is very big, and if your network has so many different kinds of sensors, they will produce a lot of alerts and logs. If you take this example, think of a scenario where you get an email from a malicious person, right? Malicious attacker, and that email comes to your environment, and let's say it has a phishing link, and that phishing link, if someone clicks on that phishing link, he or she will be taken to a malicious site, and maybe that person will click on an image, or maybe a thumbnail or a video, and there will be a drive-by download coming into his or her PC's memory or laptop's memory, and then there will be an execution. Additional payloads will be downloaded. There might be privilege escalations, lateral movements, data exfiltrations, and evidence deletions. So it's a complete set of activities. So that's multi-stage and multi-vector. Multi-vector means it has different verticals: email, web, network, endpoint. Multi-stage means it comprises of different stages: initial access, initial exploit, privilege escalation, the lateral movement, data exfiltration, so different stages. So if you think of the cyber kill chain, you will understand the different stages. So if you want to see the full story, then you need some kind of a correlation, right? If not, then you will see the email security solution will see the email coming. The endpoint security solution might see the drive-by download, but you can't correlate the full story, right? And to do that, you need advanced algorithms and artificial intelligence. So if you take a human, so we can see the bigger picture, because we have the cognitive ability to analyze various things and make sense of various inputs that we get. So in the same manner, if you take something like XDR solution or SIEM solution, you need to that solution should have this cognitive ability to understand in a broader way. So that is where machine learning algorithms are applied. Then prioritization and triaging. So you can't respond to all the alerts that you get like within a day. So you have to filter and prioritize. For that also, so you can prioritize based on risk, or maybe you can prioritize based on the impact, or maybe based on the asset value, or maybe based on the user value. So there are different mechanisms of prioritizing. And for that, you need these sophisticated algorithms as well. So impact scope, maybe it could be an application, user, or device. Impact scope assessment is very critical in incident response. So this is an area where machine learning is also applied. So understanding the context. So when we meet a person, we ask questions. Where are you coming from? What do you do? What's your profession? Who are you? What's your name? We ask questions to understand the context about that person or the environment. Who, why, what, when, where. In the same manner, within an information security solution, we need to understand the context, right? So these kind of questions will be asked by the solution within that environment. I mean, not exactly these verbal questions, but similar things, to understand the context. So this is where machine learning is applied again. Root cause analysis. So when you are doing incident response, you have to identify the root cause to prevent that malicious attack from happening again, right? So you need to identify the root cause. You need to do investigation and forensics. For that, you need machine learning to analyze the historical data of the data lake. Then predictive analytics. So you have a set of data, you predict what is going to happen. That is called predictive analysis, and it's a big part of machine learning as well. So SIM solutions can do that. XDR solutions can do that based on user activities, so risk analysis, so endpoint behavior or application behavior or certain other telemetry data. We can predict that something is going to happen. Okay. For that, you need advanced machine learning algorithms. Investigation. So as I mentioned earlier, investigation is done in real time or maybe on historical data. For both the parts, you need AI and ML. And most importantly, you need AI and ML to detect unknown threats, right? Because there are a lot of zero-day vulnerabilities, and there will be zero-day threats as well. So there will be no signatures. So signatures can't be developed for zero-day attack, and for that you need to have these behavior modeling, machine learning, and AI techniques. So that's where that is a key area of machine learning. Okay, some of you might have seen this, but some of you might not have seen this. So that's a professional information security professional called David Bianco, and he actually developed this pyramid of pain. So in this pyramid of pain, there are different stages, right? So at the bottom layer, you have hash values, then IP addresses, domain names, network host artifacts, tools, TTP. So these are the things attackers would use to come into an environment. And as information security professionals, our duty is to identify these things. So if we try to identify something based on hash values, let's say a file or something based on hash value, pretty easy. One-to-one match, the hash values match, then it's pretty easy. We can identify. IP address, again, easy, not that hard. Domain names, simple, but there are certain mechanisms that attackers would use to bypass static domain names using these domain name generators and all. So it's simple, but maybe a bit complicated than IP addresses. But network and host artifacts. So when attackers come into your networks, they leave a lot of artifacts in the network, right? A lot of traces in routers, switches, firewalls, and other endpoints, the application layer, the devices. So trying to make sense out of it is not easy. It's kind of annoying. So when you go to the upper layers from the bottom layers, you see that the tasks of an information security analyst get harder and harder, right? And when it comes to tools, so attackers have different tools, command line tools, like software-based tools, etc. And trying to detect them and block them is not easy at all, because they have their native capabilities of bypassing certain things, and those applications and tools will have their own machine learning and AI capabilities sometimes. So it's challenging. Then in the top, we have techniques, tactics, and procedures. So attackers, so we'll talk about MITRE framework in a bit as well. So in there, you will be able to see what a tactic and a technique are. And when attackers follow these things, the spectrum is very vast and it's extremely tough to identify these TTPs. It's not easy. So machine learning is mostly applied to detect attacks and threats coming in these top layers in tools and when the attackers follow these TTPs. Right. So this is why machine learning is needed. Okay. So our journey is to go from known to unknown. Okay. So when you go from the top solutions I have mentioned here, they are for they are to identify known solutions. But when you go down this list, the bottom ones are focused on identifying the unknown ones. So when you go from top to bottom, the difficulty goes up. And using these lower level technologies, you can identify and detect unknown like malware and attack. But using these simpler ones like signatures, you can detect known ones. Signatures pretty easy. You see something, you analyze it, and you create a signature. You know, a signature is something static, right? Using that, I mean, like if we take our signatures, it's always the same. Mostly, I mean, like. Signature could be a bad example, but if you take an application signature or something, it's always the same. That application is static and it has a unique behavior, and it doesn't change. So it's always the same. So we can identify those characteristics, and we can create something like a fingerprint. Okay, so that is signature. Expert rules are something like if, then, else statements. So you create these rules manually. Depending on the attack, so you say that okay, if this is happening, and if that is happening, and if and else this is not happening, there's a like an effect. Okay, expert rules are something like that based on logic, and these rules are pretty long, and you have to configure them. But expert rules can identify certain malicious events or malicious files going beyond signatures. Fuzzy match. So fuzzy match is basically if you want to search for something. Let's say I want to search for a certain word, and we type it in Google, type it on Google, and the Google will give you exact matches as well as like matches for like words, similar words. If you search for the word Google, the results might come for words like Google, right? Google, or because like those are kind of similar words. So in fuzzy matching, even though the user doesn't exactly type a word with the exact kind of string, there will be results coming in for similar words with a slight variation in the string as well. And when it comes to machine learning as well, so when it comes to information security as well, using fuzzy match, we can identify certain malware which has a slight variation from the initial one. You get it? So like even though it is not an exact match, we can identify like different variants with a slight variation. In similarity hashing also, we try to identify characteristics of malware, and we try to develop hashes so we can identify other malware which have the similar characteristics. So it's like putting similar items which are not exactly matching into different baskets, right? So if we take the hash, it should be an exact match. But if we take similarity hashing, we can develop that hash value based on different characteristics. And if the other malware has the same characteristic, I mean like similar characteristic, it will be categorized into the malware basket, right? So it's something which goes beyond normal hashing. In supervised machine learning, so what happens is that so we will talk about supervised machine learning and unsupervised machine learning in depth in the coming slides, but just to give you an idea here, supervised machine learning is that you know something and you teach the model based on your understanding of that thing. Let's say there's a teacher. The teacher knows what is 2 by 2. Okay, the teacher knows what is 2 by 2, and until the student gets it right, we teach it. We know 2 by 2 is 4, And until the student gets it right, we train them to do what we want, to get the output that we desire. So we supervise it, right? So we'll talk about that in depth in the coming slides. Data stacking. Data stacking is pretty interesting. I mean, it's like you collect data and you stack them. And I mean, like, let's say you deploy a solution in your environment, and maybe for a month, that solution will be collecting data and creating something like a baseline. On top of the data, it will be storing data, stacking them, and it will try to identify the patterns in your environment. It is creating something like a baseline that it can act upon. So that is basically data stacking. So we'll talk about that more in the coming slides. Unsupervised machine learning is there's no teacher, no one knows what's going to happen. The algorithm will have to learn on his own. If you take Tarzan, and he was abandoned in the forest, and he had to learn everything by himself. There was no one to teach anything. So usually humans speak a language, but Tarzan somehow managed to learn to talk with animals, according to the stories that we read, right? Or Mowgli in a similar story. So in unsupervised machine learning, also you don't know what is going to happen. You just feed data without categorization or anything, and the machine learning algorithm will extract them, analyze them, and will identify the different characteristics, and it will come up with something on its own, and something it could be a totally different thing from our desired level as well. But we can alter the algorithm to get what we need. So it learns based on the experience. Okay. Okay. So when it comes to machine learning, it's critical for us to understand a basic definition. So this is actually the textbook definition of machine learning. Arthur Samuel was a pioneer in machine learning in 1950s, and he was actually the person who brought in this concept of not brought in, I mean, like, who actually marketed this concept of machine learning and artificial intelligence. So he did a lot of work there. So according to his definition, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. Okay, we are not going to tell the machine what to do. I mean, like in programming, you actually type in certain things. Okay, for everything you have to type in code. But in machine learning, you don't exactly tell the computer to do something. Okay, and so these are sophisticated programming levels, implementations where the code allows the machine to learn by itself. Okay, so maybe some of you might have tried implementing machine learning algorithms, and some of you may know certain things about implementing it better than me. But this is the basic idea that you need to take out from the session. And also, as I said before as well, these algorithms can learn through experience. That's the most important thing. Okay, this is Arthur Samuel. So I just put this picture to give you an understanding about what happened in 1950s. So probably this room, the whole room, can be put into a wristwatch. But actually, he developed certain initial programs in machine learning, like checkers playing program, and it was one of the world's first successful machine learning programs. And this picture actually shows how he used to work on this algorithm using these very legacy equipment. Like you can see these tape devices and all in this picture. So it's pretty interesting how far we have come within 60 years of time. Okay. Okay. So when it comes to artificial intelligence, machine learning, and deep learning, people actually use these interchangeably. So artificial intelligence is the broad and high-level scope. Okay. In artificial intelligence, we teach programs to learn and reason like humans through logic and through maybe if then else statements, through machine learning, through neural networks. So machine learning and deep learning are part of artificial intelligence because it's the higher spectrum. But artificial intelligence could be something like simple logics or if then else statements. So if you had used computers in 1990s or early 2000s, there were very simple chat applications. So we used to like call them AI application those time. When you type in a question, that application would give you an answer. So those are like it's kind of trying to mimic human behavior. So it's that's also kind of artificial intelligence as well. But those are specifically coded. Okay. But when it comes to machine learning can learn on its own without being explicitly programmed. Okay, so it's going beyond these traditional artificial intelligence. I mean, machine learning has two parts, two main parts, and one is very close to the actual human behavior as well. We'll talk about that in the coming slides. But machine learning is a part of the big picture artificial intelligence. Then comes deep learning. In deep learning, we actually try to mimic the neural network in our human brains. So those are very sophisticated and used for very advanced solutions. I mean, not exactly in cybersecurity field. I don't think that we use deep learning in cybersecurity field as of now. But maybe in future, like deep learning could be used to mimic the information security analyst. But for now, we can't eliminate the human factor for now. But in future, probably the human factor might get eliminated as well using deep learning technology. So it's a subset of machine learning where the human neural network is like a mimic. And so it can actually process vast amount of data and have a cognitive ability, have kind of a cognitive ability closer to humans. That's actually the expectation, but we have not gone there. But in future, it might happen as well. Okay. Slides change. Right. Okay. So difference between traditional programming versus machine learning is that in traditional programming, we feed the computer with the data and the program, and the computer will give an output. But in machine learning, we don't feed the computer with we don't feed the computer with the program. We want the computer to develop a program for us. So we put data and certain outputs, and the computer will develop an algorithm for us, so we can test other data using it. So that's the difference between traditional programming and machine learning. Okay. Now we actually come to the interesting part. Supervised types of learning. I told you that machine learning has different areas. The main two areas which are applicable in information and cybersecurity are supervised machine learning and unsupervised machine learning. In supervised machine learning, we have data which are explicitly categorized, labeled. Okay. Let's say we have two sets of pictures, cats and dogs. So there's a set of pictures labeled cats, and there's another set of pictures labeled dogs. And we feed those set of pictures to the machine learning algorithm. When we feed a picture of a dog, we tell the machine, this is a picture of a dog. When we feed a picture of a cat, we tell the machine, this is a picture of a cat. So the machine knows this is a picture of a dog and this is a picture of a cat. And it will actually analyze the unique characteristics of each of those pictures, and it will develop an algorithm. So when another picture is fed, it can label it as cats or dogs. Okay, we have the label categories and we feed the algorithm with those labels. Okay, then if we after the algorithm is generated, if we feed another picture of another cat or a dog, maybe it's a new cat which was not in the initial set of test data. The algorithm will analyze it and it will detect it and it will say whether this is a cat or a dog. Okay, you have labeled data, you know what the output is, and you tell the machine learning algorithm what the output is. All the test data are labeled, so the machine can easily identify the unique characteristics under each label. Okay, this is supervised because you know the output and you train the algorithm to do what you want. Okay, but there are certain issues as well. I mean, everything depends on the quality of the data. If you haven't labeled the data properly, then there will be issues. So you have to be very clear when it comes to supervised machine learning that you properly label the data. This is an issue in information security and cybersecurity solutions as well. So when they want to train the solutions using supervised data, they need to be 100% sure that they have properly categorized malicious activities, so malware or advanced ransomware, and normal files or processes of data. If the categorization is not good, then the machine learning algorithm will be bad as well because their learning capability will be affected. And also, if you don't have enough categorizations, then there will be a problem as well. So if you take the example of cats and dogs, and if you try to feed a picture of a leopard or a wolf to the algorithm, then the wolf might be identified as a dog, or the leopard might be identified as a cat. That is because you don't have enough categorizations fed into the machine learning model. So you have to be sure that you are feeding the adequate number of categorizations. I mean, like if there are like 1,000 animals in the world, so the machine learning model should be fed with 1,000 animals. So otherwise there will be issues. Okay, right. I hope you got the concept of supervised machine learning. Then the second most important categorization is unsupervised machine learning. Here, you have not labeled the data. The data is not labeled, not categorized. It's like a lake of raw data. You feed it to the algorithm, and the algorithm will have to make sense out of it. So if we take the example of cats and dogs, now you have not labeled the pictures. You have not categorized them into different labels. You mix it up and you feed the complete set of pictures to the algorithm. So the algorithm doesn't know which ones are cats, which ones are dogs. So it will have to identify different characteristics, and it will have to like do like a lot of analysis and to identify unique features and all. And it doesn't know about a cat, it doesn't know about a dog, but it will somehow try to like categorize those data into different classifications, and it will actually come up with different names. Maybe now it's not cats and dogs. Now the algorithm might call them A or B because it doesn't know about any output, right? That is the thing. So the algorithm will have to learn on its own. There's no one to guide. There's no one to supervise. You are just feeding raw data. Okay, this is actually applicable. In information security because you can just feed all the data to the algorithm. I mean, you are collecting a lot of data from customer environment. I mean, not you, but information security vendors, they collect a lot of data from customer environments. So they can basically feed all the data into the machine learning algorithm, unsupervised machine learning algorithm, and it will try to characterize different things after analyzing. Okay. Right. Okay. This is again unsupervised and supervised machine learning. I just want to show you different methods in supervised machine learning and supervised machine learning. In supervised machine learning, we have two main methods: regression and classification. So classification is basically for those data that you can explicitly categorize. I mean, there are cats, there are dogs, there are leopards. There's nothing in between. I mean, there are no half animals, right? You can basically categorize each animal into one category. You can give names, right? So those things that you can explicitly classify or categorize will come under classification. So some applications like image classification, diagnostics, like maybe fraud detection. So in image classification, you can actually categorize, like identify an image and say whether this is a human, a dog, or a cat, or an elephant. So you can classify. So it will come under there. And in regression, that deals with the continuous data. So if you take a price of a house and the number of square feet. So when the number of square feet goes up, the price will go up as well. But there's no specific categorization. It's a continuous thing. We know numerical values are continuous. If you take population growth, life expectancy, market forecast, those are continuous functions. And for those continuous functions, we need a regression analysis. And in unsupervised machine learning also, we have two things: clustering and dimensionality reduction. We don't want to go into depth. Clustering is also basically like if you want to do some market analysis and if you want to analyze some customer data and do some customer segmentation based on various demographics and characteristics, or maybe if you want to do some targeted marketing based on different features of market cluster, then you will be applying clustering, because you need to group different things based on different characteristics. But these characteristics are very vast, and like supervised machine learning will not work, and because like there are so many things that you need to analyze. And in dimensional reduction, what you do is when a lot of data is fed into the solution, you try to reduce certain dimensions. You try to reduce certain features. And in machine learning, we categorize features in vectors. So in dimensional reduction, you can eliminate certain features of these vectors and come up with meaningful information, right? So what you need to understand is that there are two main functions: supervised learning and unsupervised learning, and you need to see how these are applied in information and cybersecurity solutions. Okay. Right. So in supervised machine learning, there are advantages and disadvantages. In unsupervised machine learning also, there are advantages and disadvantages. Okay. If we take supervised machine learning, we have input labels and we have output categories. But in unsupervised machine learning, as you saw earlier, we don't have input. We don't have input labels. We only have input data. Accuracy, supervised machine learning, accuracy is pretty high because you have already labeled the data. You tell the machine these are the labels, so it knows what to do. But in unsupervised machine learning, you have not categorized the data. The algorithm has to learn from its own, and the accuracy will be less. And if you take, let's say, learning method, in supervised machine learning, it's kind of offline because you are feeding historical data. But in unsupervised machine learning, mostly it's real time because you are giving it live data. And when we take computational complexity and all resource consumption and all, supervised machine learning, not that complex, it's pretty simple. But in unsupervised machine learning, they are very complex because unsupervised machine learning, they have to do a lot. Okay. And in supervised machine learning, you know the number of categories. If you know all the names of the animals in the world, and if you have a set of pictures for all the animals, then you know that's a limitation. But in unsupervised machine learning, since the algorithm is learning by itself, there's no limitation. It can come up with maybe even when you feed cats and pictures of cats and dogs, the algorithm might categorize them according to different classes. Who knows? Maybe white cats, white dogs, black cats, black dogs, right? So there will be different things. Even though you see it as cats and dogs, the algorithm might come up with different things. The number of classes are unknown, right? So these are some of the main differences between the two classes of machine learning. Okay, so I'm just going to present you some use cases of machine learning in cybersecurity, but I don't want to go into depth. These are some very high-level things that you will see every day. Okay, these are pretty simple things, but since there could be like newcomers and freshers and people who are trying to enter into cybersecurity as well, I just entered it. So in almost all the cybersecurity solutions and technologies that you see in the industry, machine learning and artificial intelligence are embedded. Okay, it could be simple malware detection, advanced ransomware detection, variant protection, and APT, email ATP, advanced threat prevention. In ATP, anyways, you need machine learning and machine learning kind of things. Phishing, right? And phishing also not only detecting the link in the email body, but sometimes when you go to a website, there are people can actually design a website which is similar. If you go to Facebook, there's a landing page, right? And people can actually design similar landing pages in phishing. In phishing, the sophisticated web security, there are sophisticated technologies to do image analysis and identify the difference between attacker created similar page and actual landing page, right? Using machine vision technologies, there are solutions which can identify that, and for that purpose you need ML and AI, or maybe bots, or maybe to eliminate human errors. Okay, so in information security, you need to reduce manual work as much as possible. You need to automate as many things as possible, because humans are humans. They make mistakes, they get stressed, they get fatigued, they get overworked, and they tend to overlook certain things. They make mistakes, they make misconfigurations. So you need to eliminate as much manual work as you can, and you need to automate things. And to automate things, there should be a solution which can mimic human behavior with less errors. So that is where ML and AI come into play. And if I'll just you can go through these things later in the recording. I'll just randomly pick things up. SMS scams. So in the last 2 years, we actually saw an increase in SMS scams. Okay, you can't actually develop a signature to a SMS, a malicious SMS, right? But sometimes when we, as information security professionals, when we see malicious SMS, we know what it is from the format, or maybe maybe the use of words, or maybe the link and everything. So you get a feel, right? This is malicious. Maybe the use of emojis and all. But you can't develop a signature because different SMSs will be different. But machine learning can be used to identify these SMS scams and account takeover. And so now account takeover activities are pretty sufficient. And these are things where you can't develop a signature. So ML will play a huge role. And some newer technologies like deception technologies. If you know about Gartner hype cycle, they also highlight these things, deception technologies. So here we try to fool the attacker. You might have heard about honeypot, but honeypots were simple things. But now we have sophisticated solutions which have special capabilities to fool attackers, called deception technologies, right? And breach and attack simulation, a new concept, a new solution. Usually we know about VAPT, vulnerability assessment and penetration testing, but now there are solutions which customers can implement in their environments, and they can create their they can create attack workflows to identify the misconfigurations and loopholes in security devices. So breach and attack simulation is a hot area right now, and machine learning and AI is used there as well. Application security, web application security, you can like make the solution aware about SQL injection, cross-site scripting, and advanced DDoS attacks. Okay, because these are things that you can't exactly develop a signature. And zero-day threats, unknown threats, and like you need to have ML to detect those things, because we don't have signatures. Those are new things. Okay. And XDR, I spoke about XDR, and I will be speaking about XDR as well. So when you need to analyze a large lake of data, you need to have special cognitive capabilities and automating responses. So now we have SOAR solutions, and we in most of the modern centralized information security defense platforms, we have automated responses. We have playbooks, right? So those can be automatically implemented. I mean, users don't have to do anything. When the solution detects that there's a threat, there will be automated responses developed. For that, you need ML and AI. So go through this list separately, because there's a lot to cover. So I don't want to go into detail about everything. So again, there's a very big area called anomaly detection. Anomaly is something not normal, basically, right? So everything in the network might have an anomaly at a given point of time. To detect anomalies, you can't use signatures, so you can't usually use unsupervised machine learning as well. Sorry, supervised machine learning as well. So for that, you need to have unsupervised machine learning. Okay. So these are some of the unusual things that we could see in our networks: browser behavior, or maybe RDP, SSH, data transfers, account logins, USB plugins, SAS logins, suspicious read or writes, maybe suspicious command line operations. There could be a lot of things which are happening in your network. And for that, you need unsupervised machine learning. So the idea is that when an information security solution vendor or a presenter comes and tells you that we have a ML, we have an AI, we have data stacking, we can do this, we can do that. So ask them specifically which technology will be applied to detect a certain kind of threats. That you need to know actually. The idea of this session is to give you an understanding about different components, so you can ask the presenter. You can ask the solution vendor. So if he tells that we can do with this machine learning, ask them, which machine learning are you going to take? What kind of a model? How it is trained? Right? What kind of an unusual activity or anomaly will be detected? So those are the things that you can actually ask from the vendor. So that you can use this understanding you gain from this session. Okay. So I spoke about data stacking. And so data stacking is basically stacking the data for a long period of time, maybe in days, in weeks, in months, so you can identify a pattern. In unsupervised machine learning also, you feed the machine with unlabeled, uncategorized data, and the machine will try to characterize it and identify certain patterns or certain labels on its own. So both can be used to identify an anomaly, but they have their own advantages and disadvantages, and usually the solution vendors know when to apply one over the other. Okay, so ask the vendors whether they are using data stacking or unsupervised machine learning, and so you can understand about the pros and cons of that solution. So data stacking is basically easier to implement and explain. Machine learning is more complex and not easy to implement. But if we take an instance where, like, let's say, you create a baseline, so you have an idea about what is happening in the network, and if something is changed suddenly, then it is going beyond the pattern, going against the pattern, then you can detect it. Let's say there's a fresh user. I mean, if the solution sees a fresh user logo in the network, and if that user has never logged into the network before, then it could be an anomaly. And also, if you know all the IPs, like if you know all the communications which are going out to the external IPs, and if you suddenly see a new outbound connection for a new IP, it could be malicious. And if you see the same type of files in the network, let's say the network only sees PDF files. Okay, but if you suddenly see an exe file, it could be an anomaly, and they are worthy of further investigations. So data stacking can help you with that. But there are certain things that data stacking can't do as well. Okay, let's say there's an unusual logging at an unusual time with anomalous behavior. Then behavior modeling need also come into play. Let's say I'm a network administrator, and all the time I log into different users' machines to troubleshoot them. So it's my duty as a network administrator. So maybe logging in at unusual times is it's not that uncommon. But if we take data stacking, sometimes it could identify there could be false positives. Maybe a network administrator might be logging in to do a certain troubleshooting at night, but with data stacking, it could be identified as something like malicious. So in that time, for the network administrator's account, we need to add certain other parameters as well. That is where unsupervised machine learning comes into play. So if you look at the table below, the top one is not malicious. So these are some of the real packets captured in a test environment. The top one is not malicious. So it is like the top one is actually the data from a real admin's activity. Okay. But if you forget about the last two columns, packets and bytes, everything seems to be similar, right? Only the time is different. But if you take the columns of packets and bytes, in the first one, the number of packets and number of bytes are higher. Okay, if like normally when network, I mean like these are some like these are like only 3 rows, but there are other rows of other data as well. But when normally the network administrator logs in, he does certain file transfers, maybe like a lot of typing or maybe transfer of a certain tool, etc. So the number of packets and number of bytes are high. But when an attacker logs in, they want to keep it short. They just type in a command, collect some information, and logs out. So if you can like collect these data for a longer period of time and feed them into unsupervised machine learning, then they will actually monitor these things and like identify malicious activities. Right? So data stacking might not be able to do that. Okay, let's go for another example. If we take unsupervised machine learning, if we take an email security solution, these are different rules that you might see where data stacking. So I can't tell you about all the solutions, but if you build up the thinking pattern, you will be able to see which are using supervised machine learning, which are using unsupervised machine learning, and which are using data stacking. So I took a very simple example, but you can when a vendor comes and tells you that they have these kind of rules, you can ask them whether they are using unsupervised machine learning, data stacking, no, expert tools, or supervised machine learning. Okay. So if an account has logon activities coming from a new geolocation, so as we spoke earlier, if we have a developer pattern, then we can identify it using data stacking, right? But if a certain message routing path is inconsistent with previous record, then you are also analyzing a lot of data which you have been collecting for a longer period of time. So unsupervised machine learning and data stacking would be good. But if you go to a simpler format, I mean, I don't know whether you have heard about something, writing style DNA. So there are certain solutions which can actually analyze and email users outbox, the sent items actually, and identify his or her writing style. Okay, each of us have a unique writing style. We have our own like punctuations, emojis. grammars, word, and like paragraphing. There are a lot of things unique from each user to each user. Okay, and there are email security solutions which can actually analyze the outbox or the sent items, sent emails, and develop a DNA or something like a fingerprint for each user. Not a fingerprint, actually a DNA, like an analysis of the writing style. Okay, so if we can apply supervised machine learning and expert tools to that email sender's account, then we can identify phishing attacks, business email compromise attacks, or malicious emails which are going out from that user's account. Okay, or malicious emails coming into that user's account. Because we know what is good, we know what is bad, and we can explicitly tell the machine learning algorithm what is good and what is bad, and then it can create the model based on that categorized data. Okay, and in the last example, I mean, if as I mentioned earlier, if someone is seeing a new file type in the environment for the first time, then unsupervised machine learning or data stacking can identify it pretty easily. Okay. Now, in information security solutions, you might see filters, rules, and models. Okay, these are some of the keywords that solution vendors use. So, if you take filters, filters are the most fundamental units in a solution. We can implement a filter using expert tools, data stacking, or machine learning. Then there are rules. A rule will have one or more filters. So the most simpler part is a filter, which is created using expert tools, data stacking, or machine learning. Then you have a rule which has one or more filters. Then we have models. A model is used to identify something and generate an alert. Every time you hear the word machine learning models and everything. So a model has different rules, and a model will have one or more rules, and a rule will have one or more filters. That's how the hierarchy forms. So if a solution vendor comes and tells you about filters, rules, and models, now you can have an understanding about what they are talking about. So you can ask them how the rules are formed, how the filters are formed, whether they are using expert tools, data stacking, and machine learning. So you know whether they are doing the right thing or whether they are doing the wrong thing, and the pros and cons of applying a rule, a filter, or a model in your environment. So there are two main two main stages of machine learning detection. One is called pre-execution machine learning, and the other one is called runtime machine learning. So in pre-execution machine learning, you analyze the static characteristics of a file. Okay, you analyze the static characteristics of a file, then you you predict whether that file is malicious or not. It could be the true file type, or it could be the data distribution of that file. I mean, like the binary data statistics, or it could be certain text strings, or maybe file format descriptions. So those are everything static before executing the file. That is at the pre-execution stage. Then there's something called runtime machine learning, which is applied when the file is executed or when a process is executed. Okay, so when a process is executed, there are certain things which happens in the CPU level and the memory level. Okay, so when a process is broken into the lower layers, we call it the opcode, operation code. Okay, and there's something called API calls as well. So we have the opcode, we have the import table. Import table is the table that is or the array of information that is imported to the memory when something is executed. Those memory addresses and commands and instructions and all. Okay, so in runtime machine learning, the solution usually analyzes that. Okay, so this is what happens. So like there are certain solutions which use runtime machine learning. There are certain solutions which use both runtime machine learning and pre-execution machine learning. And there's an advantage if you use both the solutions. You have to ask the vendor what kind of machine learning and which stage are you using it. So I'm not going to go into depth about this thing, but this is the opcode of a certain opcode of two different ransomware. Both are malicious, but for the first one we have a signature. For the second one we don't have a signature. You see, the green ones are the similar steps. So both the ransomware have similar steps, the green ones, but they have different steps as well, the red ones, right? But if you break it down into different, now if we try to create a signature for the first ransomware, the signature will not apply to the second ransomware because there are red ones, because of these red ones, the differences. Okay, so that's why you need to apply runtime machine learning where you normalize these things, where you normalize the opcode, where you normalize the import table, and you create these graphs to like identify whether a certain thing is malicious or not. So if you normalize the data of the first ransomware, and if you normalize the data of the second ransomware, you see that both are similar. Now you can predict whether the second ransomware is malicious or not. So that is the advantage of runtime machine learning. Like you identify the opcode and the API calls and the import tables and all. So you get the decision then and there. Okay. Right. Then I'm not going to go into a lot of detail about it, but there's something called MITRE framework. So MITRE has tactics and techniques. Right? Tactics are something like a vision, the ultimate dream or the goal that someone wants to like acquire or achieve or reach. Right? Then we have techniques. So techniques are like the mission. So to like reach a certain mission, you can go through certain missions, right? You can apply certain procedures. There are certain different paths. Let's say in MITRE also they have tactics and techniques. So at the initial horizontal level, you see the tactics, but under each tactic you have different techniques. So if you take the initial access tactic, so you have to get the initial access. So if a malicious intruder wants to get initial access to a system, he can go through different techniques. Maybe send a phishing email, maybe do an initial exploit, maybe send a ransomware, or maybe let's say maybe a supply chain compromise. There are different things that they can do, right? Tactics and techniques are very important because now almost all the security vendors, not almost all, every security vendor right now apply MITRE framework in their solutions for detection, prevention, and response. So when it comes to MITRE techniques also, most of the MITRE techniques can be covered through expert rules. Okay, so vendors will come and tell you that they have detection and response capability, prevention, detection and response capabilities aligned with the MITRE framework, MITRE techniques and tactics. So ask them how these techniques are covered. So expert rules can cover most of the techniques, and data stacking and machine learning are used to cover a smaller portion. Okay. That is because you don't need data stacking and machine learning for everything. Okay, these are not God-sent things. They have their own limitations. We'll talk about them later. So when you can use simpler technologies, use them without, you have to use them without depending on machine learning and data stacking and advanced algorithms. Okay, so ask vendors how these MITRE techniques are detected, whether they use simpler ones or whether they use advanced ones. So for you to get a better understanding of the solution. So now time is also running out. So I'll quickly walk you through some of the, I don't know whether the presentation can be shared, but I hope the recording will be shared to go through these things later. And so these are some of the real life implementations of different vendors. And so they are adopting different architectures to implement these machine learning and AI techniques. So this is the Windows AV Defender of Microsoft, and as you can see here, these are client side. Okay, the upper two parts are client side, and the bottom parts are cloud based. So you have client side machine learning as well as cloud based machine learning. So if we like using this cloud client side machine learning, you can detect things very fast. So here they say that protection is in milliseconds, right? Millisecond detection. But when it comes to the lower layers, it becomes seconds, minutes, and hours. So these are different machine learning models: local ML models, behavior-based detection, right? Heuristic algorithms. So those are all client side metadata. So you know everything in the machine has that metadata. So we can run these things in the client side. But if you want to analyze a certain sample, if you want to detonate it, if you want to dynamically analyze it, so you have to send it to the cloud. Then to apply machine learning at that level, it will take time. So millisecond becomes seconds, minutes, and hours. So this is their architecture. Okay, and this is the architecture of Trend Micro. So in Trend Micro, in endpoints, they use a combination of legacy technologies as well as advanced technologies. So you know, at a given point of time, you can actually given point of time, you get a collection of known good data, known bad data, and unknown data. So all these things will be sent through the security solution. So by applying initial legacy technologies, they can detect good data and bad data. Then Trend Micro has pre-execution machine learning. Based on the static characteristics, they identify something. Then they have runtime machine learning and behavior analysis. So they identify it at the runtime, and they go for the final stage. So that's their approach: legacy technologies plus pre-execution machine learning and runtime machine learning in a layered manner. Okay, so this is how they use it. Read on this if you want later, but identify the architectural differences. And this is the XDR cloud of Trend Micro as well. So here, if you see, so at the initial layer, they collect all the raw data and activity data and telemetry data, and with suspicion, with known bad data, things that you prevent. And at the next layer, they apply data stacking, expert rules, and machine learning. And they say that they only use machine learning and data stacking only for like 20% or 30%. They depend on other techniques up to 80%. Right? They don't completely depend on machine learning, supervised machine learning, or data stacking for everything. Right? They don't depend on AI for everything. Right? They use that only for a certain portion of the detections and response activities. Okay, that's how they actually implement the solution. Okay, so this is what CrowdStrike does. In CrowdStrike, to train the models, they have something called they have manual analysts as well. So when CrowdStrike machine learning algorithms categorize something as malicious, so not malicious, they actually there are humans who actually analyze these categorizations and verify them, right? So when here the protected environments will feed the feature vectors and metadata of the cloud, and they will in the machine learning algorithm they will come up with certain categorizations, and it will be verified by CrowdStrike analysis team as well as dirty samples or clean samples to train the data, train the algorithm in a better way. Right. So this is what Darktrace does. Darktrace is an enterprise immune system, or we call it like network behavior analysis or network detection and response. There are different names. And so it collects data from all the physical machines, virtual machines, clouds, users, applications, and everything. And using recursive Bayesian estimation, the people who might have done maths for their advanced level, or maybe in university, they know what Bayesian algorithms are. So they have these unsupervised mathematical detections to analyze that network data and model human behavior, device behavior, network behavior, and create a baseline. So that is how they have applied machine learning and AI to model certain behaviors, model the behavior of humans, devices, and networks at the network layer. Okay. One thing you need to understand is that what is the difference between AI versus IA? AI is artificial intelligence, IA is intelligence augmentation. So every solution should try to achieve intelligence augmentation through artificial intelligence. You can't eliminate the human behavior completely. That's not possible. Human should be there in every information. Human factor should be there as analysts, like to supervise things. So what the solution should do is they need to augment the cognitive capability and the skill levels of humans. They need to make these solutions should make humans' lives easier. So that is called intelligence augmentation. They are human intelligence is taken to another level using artificial intelligence techniques, right? That is what these solutions try to do, to augment our intelligence. Okay. Right, so we are coming to the final parts of the presentation. Limitations of machine learning algorithms. So I'll go through these things quickly. Some of you may already know these things. High resource consumption. So machine learning algorithms are sophisticated. So when you run them in your endpoint or network layer or firewall or whatever, resource consumption will be high. And they have high false positive rates. Okay. That means like you can't solely depend on machine learning only. You need to know where to apply them and achieve a balance, right? Because their false positive rates are high. Then, as I mentioned earlier, they depend on the quality of the training set or the training data. You have to properly label them and you have to sanitize them, and you have to make sure that the data is coming from the right source as well. Otherwise, if they got polluted and if you are not feeding the algorithm with the right data, then the detections or the model that you develop will be wrong. I mentioned this as well. Data should come from one cohesive source, or algorithm will not function properly. Source is very important. And other thing is that certain solutions need internet connectivity for machine learning to work properly. So check that when vendors come and tell you about solutions. So there are certain endpoint security solutions where machine learning doesn't work without internet. So that you have to check. There are certain solutions where you can actually run machine learning algorithms within the solution or within the endpoint or the network device itself. They don't need internet. But their limitations could be, but their capabilities could be limited. So check that. What can be run with the internet? What can be run without internet? What can be run with both of them together? That is how you develop your architecture. Don't depend on what they say. Ask these questions and get them sorted. So final 2-3 slides. Machine learning attacks. So there are few kinds of attacks that attackers would adversaries deploy in their against solutions or solution developers. So we have two main phases. So one is the training phase, the other one is the testing phase. Training phase is where you train the algorithm, where you train the model. Right? Testing phase is where you actually test the model. Right? So in the training phase, attackers might try to access the data set, so they can get a glimpse of some data and try to create a substitute model. So they can use that in the testing phase to get something done. So they try to access the data, right? Then we have something called data poisoning attack. So in data poisoning attack, attackers will try to pollute the data. They will put malicious or unwanted or polluted data with the normal data stack. And when you feed that data into the environment, and when you apply that data into the machine learning model, the model will be polluted because you are trying to learn from poison data. Okay, the data is not accurate. So if someone is trying to teach us with a malicious intention of like if that person's head is not right, then eventually those things will come into our behavior as well. That's what happened. The data set is not right. Then we have evasion attacks. Okay. Then we have evasion attacks. Here, what the attacker is trying to do is they try to evade the machine learning model through slightly manipulating the data that they supply. So if you take these pictures, right, the attackers will try to change maybe a pixel or maybe two, maybe 3 pixels. So they will decide what to change. So they are changing the quality of the pixel of these pictures. Even though this is a ship, the machine learning algorithm will identify it as a car. So these are evasion techniques. I mean, like, this is a simple example of pictures, but you can go beyond that as well. So the attackers know what to change in a certain file or a process or maybe a picture or something, so they can evade the machine learning algorithm. So these are evasion attacks. Okay. Finally, we have something called oracle attacks as well. So in oracle attack, the attackers will try to infer, deduce some information on the model, right, or on the training set. So they try to deduce, so infer, assume some information on the model of the training set, so they can make use of it. And some of these attacks will not, some attacks are not that common, but extraction attacks could be common, where the attacker actually tries to extract the parameters of the model. I mean, like, if we have access to the solution and if we can feed enough data to it, and the solution will be predicting a lot of things, right? And based on the analysis of the model, based on the prediction of the model, maybe attackers might be able to infer some solution. So attackers might be able to infer some parameters of the model, and maybe they can use that data to go beyond that model. So those are extraction attacks. They try to extract certain information about the model. And we have inversion attacks. So here the attacker actually tries to reconstruct the training set based on the based on some information they gather. So if we can reconstruct the training set, maybe there could be privacy issues. So these kind of attacks, inversion and membership inference, are not that common, but it's still there. In membership inference, what the attackers do is they try to determine whether a certain file or something that you submit to the model was in the training data set. Okay, so that is inference. So these are kind of the common attacks that you can see in machine learning. And to defend against those attacks, you can use data encryption, data sanitization, and maybe statistical models or adversarial training. Data encryption, we all know, you can just simply encrypt the data. And in sanitization and the robust statistics, so I spoke about data poisoning attacks, where you try to pollute the or poison the test data, pollute the data that you feed to the algorithm. But if you can properly clean them, properly sanitize them, properly monitor them through maybe through simpler mechanisms or maybe through advanced statistics, then you can avoid poisoning attacks. Adversarial training is trying to you actually trying to inject certain you try to train the machine learning model to learn the mistakes that it would do as well, right? So you are trying to teach them what the attacker might do through slight variations of input data and test data. Right. So those are the main things I wanted to cover, and some things to ponder. So as I said, ask the right questions from the vendors, try to understand their solutions, try to understand what they say, and try to see when and where you need to apply what. Right? I mean, you don't need to depend on machine learning and AI for everything. So try to understand solutions, ask the questions, and make use of your knowledge to learn about what is right. And so that is the main intention of this. That was the main intention of this session. I hope you got an overall understanding about how ML and AI are applied in cybersecurity. So Thank you very much. And so if you have any questions, I'll try to answer. So over to you, Sujit.
Niranjan, wonderful presentation, right? And some people have messaged me saying it's been very enlightening, right? So there are a lot of things which you have shared. And I wish we should do this over a half-day session or a one-day session where we could have a variety of topics which we can discuss, right? Especially if you look at the MITRE framework, there's a lot we can debate, a lot we can actually learn from that. But there's one question from Naveen, who's based out of Bangalore. He's with Dell Technologies. He's asking any example where you have seen AI ML applied in RMF. I honestly don't know what RMF is.
Risk management framework.
Okay, risk management framework.
Okay. Yeah, of course. I mean, of course, machine learning is used. I mean, if you go into this one area, you can use this in BFSI sector, banking sector, and there are applications and solutions which try to predict things when it comes to operational risk management, budgeting, planning, and for everything, modeling and product planning and everything, machine learning is definitely applied. So they.
Niranjan, may I interrupt you? Could you like to share, stop sharing the screen? And I'm not sure whether
Sure.
always
Sorry.
back.
I forgot. Sorry. Okay.
All right. Okay. Any chance of your power back?
Oh, it's still dark.
Okay, still dark. Okay, fine. Continue.
I mean, the thing is, I was planning to join from the office, but with the issues and all, I had to work from home today.
No worries. Sorry, I interrupted your thought process. Please continue.
No, I was almost done. I mean, so in BFSI sector, operational risk management, finance planning, budgeting, machine learning and AI are definitely used.
Any other questions, ladies and gentlemen? If you do have any, you can ask now. You can unmute your microphone. If you have the luxury of turning on your camera, please do. You can ask the questions directly from Niranjan.
So throughout the session, what I could understand was there is a lot of heavy emphasis on trust and verify aspect of it, because your results is as good as your data, the input. So am I thinking in the right direction?
Of course. So if you do not feed the machine learning algorithms with the right data, so for it to learn, I mean, it's just like a child, right?
Yeah.
If you don't educate the child properly, if you don't feed the child with right content, that child will never develop, right? So just like a child, you have to make sure that you are feeding the right material, data, content, and you are guiding it properly. So then only the algorithm will be successful. I mean, you joined the CISSP class, right?
Yes, sir.
Oh, yeah,
absolutely.
I remember.
Okay, and then one last question: what are the opportunities after CISSP, just in case if I have to look at
I think Sujit
AI and ML? And
Niranjan,
question is to both.
Go first, Niranjan.
There are a lot of things that you can do actually, because CISSP will give you a breadth into a lot of areas. So you can actually decide on what area you want to specialize in afterwards. I mean, in cybersecurity areas, there's no limitation. There are plenty of things that you can do. I mean, you can go into a technical career, or you can go into a management path as well. And or maybe you can go into both areas, like becoming something like a technology officer, or maybe trying to leading a team. So it is up to you. I mean, there's no limitation, or there's no telling that you have to do this and this is the path. You have to craft your own path, I would say.
Okay, makes sense.
I mean, just to add, the sky is the limit, right? And as much as you can imagine, and I think you can create opportunities for yourself. There's plenty of them. Right? I mean, Niranjan gave some pointers in terms of from an organization's hierarchy perspective, right? Whether you want to pursue a technical career or a management career, but look at the industries, right? I mean, predominantly we saw the security being primarily discussed in BFSI, but today every organization, every sector, this is a primary requirement, and no business can consider a strategy without cybersecurity, and very importantly, without AI and ML. It can be for business purposes, it can be for cybersecurity. Yeah. Anyone else want to ask a question? Right. I assume there are no questions, but if you do have any questions, please do not hesitate to send it across to me, or you can find Niranjan on LinkedIn. He's active on Facebook as well as he's active on Instagram, right? So you can reach out to him and ask your questions directly with him. And also, if you need any help in terms of career guidance or facilitation, he's one resource who's actually come out, put his hands out and said, yes, I'm there to help, right? So some of you have met him in the CISSP mentoring program, which we had from March to May. So please reach out to him, and he's always there to help us, right? One. Number two, we're doing another event next Tuesday, and that event is going to be sponsored by Palo Alto. And again, we are going to talk about zero trust and how zero trust can help transform businesses. And of course, how can you build strategies using AI and ML? So there's a lot which is going to happen during the virtual panel discussion. And we're going to have people from Palo who join us for the session. And we are also going to have some industry leaders who will be in the panel. Right, so we look forward to seeing you on next Tuesday at 2:55 p.m. And if you do have any suggestions, or if you do see a requirement to have a presentation or even a discussion on any topic you think is important or is the current need, please send them across to me or to any of the IC Squared board members. We definitely would love to take that up in the future sessions, right? So thank you so much for being here, and we look forward to having you for future sessions. And if you've not become a member yet of the Sri Lanka chapter, the Colombo chapter, we welcome you to consider becoming a member. And we also plan to start the mentoring program again, hopefully by end of this month or early next month. And so those of you plan to pursue any of the IC Squared certifications, we would like to help you with those study programs or mentoring, whatever you may want to call it. We plan to do this free of cost for you, right? So with that note, Niranjan, I want to thank you again for the
Thank you very much, Sujit.
Awesome presentation. Slides were neat, crisp, and very, very appealing, right? I mean, there's
Thanks,
a lot
Sujit.
we could relate to. I want to compliment for that wonderful presentation. I look forward to having you again in August. So Niranjan will be doing another session in August. So don't miss it out, right? And then I also want to thank my board, IC Squared Colombo Chapter Board, for being there, strengthening us day to day, and we continue to be delivering these programs without any problems. And we couldn't have done that without their support. I want to acknowledge that, and I want to say thank you. Right? And we have Amal Hettige, who's a board member, also on this session. Thank you, Amal, for all the support, and of course, all the others as well. So with that note, I like to say good night and have a great evening, and see you again.
Good night, guys.
Next
Good night,
week.
guys. Have a great
Good night.